Okay, Bismillah ar-Rahman ar-Rahim and Assalamu alaikum. In this particular lab session, we'll be talking about functions in Octave. In fact, we'll be writing our own functions in Octave. So first of all, we need to learn like what do we mean by a function. You have used plenty of built-in Octave functions. So I hope like you have some idea about what functions are, but nevertheless, we will talk about functions. So a function is basically a block of code, okay? A block of code. In this case, when we say code, we mean Octave script code that does something specific. So if you write code to do something specific, so basically you have created a function, okay? For example, like you've used the sine function, cosine function, the rand function, the rand I function, so and the max function, the min function. We have used all these functions, and the purpose of these functions, like their purpose was very specific. You use the rand function to generate random values, random vectors. For example, the rand function generates random values or random vectors in the range 0 to 1. So you call the rand function, you give it these input values, these input arguments. So these are two input values. The first input specifies the number of rows, the second input specifies the number of columns. So it gives you a row vector in this particular case, and this row vector contains random values in the range of 0 to 1. That is what the purpose of this function is, the rand function, okay? So when you call this function, you give it some input values. These input values are also called input arguments, and it gives you some output. It gives you some output. So that is what a function does, okay? Say for example, now let us create another random vector of the order say 1 by 5, and let us store it in the variable a. Okay, let us refer to it by the variable a. Now a is this random vector. We call the random function, the rand function. We This is the name of the rand function. We gave it input arguments. These are this is how we specify the input arguments or input values, and the rand function generated a random vector, a vector of random values of these specified dimensions, and it returned us that vector, okay? So we have used other functions as well. For example, the mean function. So mean function, what does it do? We give it an input, and that input in this particular case is the vector a, and it finds the average or mean value of all the elements in vector a, okay? So we have also used the max function. The max function, what does it do? You give it an input value. If the input is a vector, so it finds the maximum value in that vector. So if we give it a as the input value, so the maximum value here is 0.7151, so it will return us this value, okay? So these are the built-in functions that we have used. You are aware of these functions, okay? Now you can write similar functions of your own. You can write similar functions of your own. Any function that you write, it must do something specific. It must do something specific. It should carry out a specific task. It should get some input values or input arguments, and it should return some output value or output arguments, okay? So that is what the purpose of a function is. So functions are very good, okay? Writing function makes your task a lot easier. So you can write or put blocks of code that do something specific into functions, and then you can reuse those functions, okay? Just like, for example, somebody wrote this function rand, and now we can use this function over and over again. Whenever we want to use this function, we just write the name of the function and give it the input arguments, and then we can use that code, okay? And we can use it as many times as we want. We can put it inside a loop, and we can call this function 1,000 times or 1,000,000 times, as many times as we want, okay? So that is the beauty of function. So usually in programming, what we do is we mostly try to solve a problem by writing as many functions as are required. Okay, so we think of a problem and then we divide that problem into sub-problems, and for each sub-problem we write a function, and then we call those functions in a particular order, and we try to solve the bigger problem. Okay, so that is usually what we do. Okay, so I'll give you small examples of these, and we'll see like how do writing functions make our life easy. Okay, okay, so this is what a function is. Now how do you write a function? Now you have used all these functions. Okay, so rand is a function, mean, max, these are all functions. Now these functions have names. Okay, rand is a name, mean is a name, max is a name. A function's name must always begin with an alphabet. Okay, so it must always begin with A, B, C, D, or something like that. Okay, it must never begin with a number. A function's name cannot begin with a number. A function's name can contain numbers and underscores. Okay, so we can have function uh, with a name that contains number. For example, we can have a function max2 or max3 or max5, whatever, if there are different ways of finding a maximum. So we can have multiple functions with maximum, or we can have mean1, mean2. Say for example, we call mean2 as the geometric mean, or mean3 the harmonic mean. Although these would not be very good names for functions, but just to give you an example, like we can have functions names like that. But we cannot have a function named 2 mean or 3 mean. Like the name of function must never begin with with something other than an alphabet. And similarly, a function name can contain underscores. So I hope you know what an underscore is. So if you look at your computer's keyboard, so you have this character. Okay, one is the dash, this is the dash, and this is the underscore. If you press the shift key and then the dash, so you get an underscore. This is the underscore. Okay, this character is the underscore. So I hope like you know what an underscore is. So function name can have an underscore as well, no problem with that. uh, the function must end with the keyword. It's not a must, like you may write a function and the function may not end with the end keyword, but it is good to have the end keyword at the end of a function. Now I said like it is not a must that you should have and you should have the end keyword at the end of function. Okay, it is not required or absolutely necessary. Why did I say that? So usually what we do is we write a single function in a single script file. Okay, whenever you are writing a function, you write it in a single script file. So you create a separate script file for that function. The name of the function and the name of the script file, they are the same. The name of the function and the name of the script file, they are the same. They must be the same. Okay, the name of the function and the name of the script file, they must be the same. And if a script file contains a single function, you do not need to put an end keyword at the end of that function. Okay, but it is always a good idea, like make a habit out of it. Whenever you write a function, so you must like end that function with the end keyword. You should end that function with the end keyword. Okay, so you should make a habit out. It is a good habit that you do that, because like a script file can have multiple functions. You can put multiple functions inside a script file. Okay, but the script file would be like known by the first function in that file. So the name of the first function and the name of the script file should be the same. And after that, the script file can have multiple other functions. Okay, that is okay. So this is what we need to take care, what we need to remember about using or creating functions in Octave. Okay. Now, I hope like you know what a function is. So let me repeat, like a function is a block of code that does something specific. A function is a block of code that does something specific, and you have come across a lot of functions that do that carry out a very specific task. For example, you know about the sine function. It calculates the sine of the angles. The angle can be a scalar value, a vector value, or a matrix. Doesn't matter. Similarly, the cos function, it finds out the cosine of the angles given to it as an input. The angles must be in radians or are considered to be in radians. And the angles can be in the form of scalars, vectors, or matrices. Okay, and the output would be accordingly either a scalar, a vector, or a matrix. You have used the rand function and the rand integer function. Similarly, you have used the max function and the min function, the mean function. And similarly, you have used other functions. For example, the plot function, the hist function or histogram function. So all these functions, they perform a specific task. They perform a specific task. They get some input from the user and they give or return some output to the user. Okay, that is what they do. Now, when you're writing a function, you must give it a name. Okay, the function's name must begin with an alphabet. It can contain numbers and underscores. Okay, so you should remember these rules. The function a function should be put in a separate script file. Okay, and the name of the script file and the name of the function, they must be the same. They must be the same. If they are not the same, you won't be able to use that function. Okay, if the name of the script file and the name of the function, if they are different, you will not be able to use that function. Similarly, a function should end with the keyword end. It is like, it is optional. You can choose to you can choose not to put the keyword end at the end of a function's body, but it is always a good habit to have it to have the keyword end at the end of the function's body. Okay. Similarly, a script file, although like it is recommended that you should have one function per script file, but a script file can have multiple functions as well. Okay. Now, if a script file is having multiple functions, how should you name that script file? Because earlier we said that the name of the script file and the name of the function should match. They should be the same. So if a script file has multiple functions, how should you name that script file? So the answer to that is that you should name that script file according to the name of the first function that appears in that script file. Okay, that is how you should name it. Okay, how do you create or write your own function? Now we said that the function should end with the keyword end. The function begins with the keyword function. Okay, so the function begins with the keyword function. After that, you provide a list of output values. Okay. In Octave and in MATLAB, this is something that uh, यानी ये फैसिलिटी किसी और प्रोग्रामिंग लैंग्वेज में अवेलेबल नहीं है मे बी पाइथन में शायद हो आई डोंट रियली रिमेंबर दैट but in C or C++, in Java, in Visual Basic, in those languages, uh, a function returns only a single value, and a function gives you a single value in the output. But in Octave, like, you can have multiple values as output, and by multiple values we mean कि y1, ये नहीं कि y1 is a scalar value. Y1 can be a vector or a scalar or a matrix. Similarly, y2 can be a vector or a scalar or a matrix. Similarly, yn can be a vector or a matrix or a scalar. So a function can give you multiple output values, So this is what you specify. You first specify the function, then you specify the list of output values. ठीक है? So कितनी output values, कितनी values आप output कर रहे हैं? You specify that, then you specify the function's name, and then you specify the input values. Function को कौन सी values दरकार हैं as input, ठीक है, ताकि वो इन पे ऑपरेट करके आपको आउटपुट कैलकुलेट करके दे. ठीक है. So this is basically the theory. Now we will write some functions. We will write a couple of functions, and I hope like by looking at those examples, you will learn something about functions. So I'll write these functions. For example, like we have looked at the problem of finding out whether a number is prime or not. So we will write a function is prime. Okay? Now, what would this function do? This function would return uh, a true or false value. Okay? If a number is prime, it would return a true value. If a number is not prime, it would return a false value. So let us write the is prime function, तो then you'll understand कि कैसे functions को create किया जाता है, ठीक है? और what is the benefit of uh, using functions, ठीक है? Or writing functions. So how does it make our life easier? So let us do that. So let us go to the editor, and a script file is already created. Let us start writing the function, ठीक है? So we want to write a function. If you want to write a function, you need to start with the keyword function. ठीक है? Keyword function, and then you need to provide the output. ठीक है? तो अगर आपने एक वैल्यू आउटपुट में प्रोड्यूस करनी है, ठीक है, से तो आप सिंपल वो वैल्यू लिख लें, रिजल्ट आउट फंक्शन रिजल्ट इज द आउटपुट वैल्यू दैट विल जनरेट, ठीक है. एंड देन अगर आपने एक से ज़्यादा वैल्यूज़ आउटपुट में प्रोड्यूस करनी है तो फिर आप जो है ना लिस्ट प्रोवाइड करेंगे. सो यू विल मेक अ लिस्ट, ठीक है, रिजल्ट कॉमा सम अदर वैल्यू कॉमा सम अदर वैल्यू. सो देन यू विल राइट इट दैट वे. अच्छा, देन दी असाइनमेंट ऑपरेटर. अच्छा, ये सिंटेक्स को आप यहाँ से फिर से देख लें. कीवर्ड फंक्शन, फिर द लिस्ट ऑफ आउटपुट वैल्यूज़. चूँकि हम एक वैल्यू प्रोड्यूस कर रहे हैं एज आउटपुट एंड दैट इज़ द रिज़ल्ट, तो आप उसको स्क्वायर ब्रैकेट्स में डालें या ना डालें कोई फ़र्क नहीं पड़ता. बट इफ़ यू आर जनरेटिंग मोर देन वन वैल्यू एज आउटपुट, देन यू नीड टू क्रिएट अ लिस्ट ऑफ आउटपुट वैल्यूज़ और फिर आपने उनको स्क्वायर ब्रैकेट्स में डालना है विद, ठीक है. अच्छा जी, then the name of the function. So this function would be the isPrime function. ठीक है? It will determine whether a number is a prime number or not. कौन सा नंबर? वो नंबर हमें इनपुट में मिलेगा यहाँ. So we'll get that number here, num. ठीक है? और you can call it as number. इसको आप नंबर का नाम दे दें. तो ये नंबर एज इनपुट मिलेगा इस फंक्शन को, इस प्राइम को. ये एज इनपुट मिलेगा. कैसे मिलेगा? वी लुक एट दैट. ठीक है, फर्स्ट जस्ट रिमेंबर कि आपको ये जो वेरिएबल नंबर है इसमें आपको एक वैल्यू मिल गई है जिसको आपने जिसका आपने पता लगाना है कि वो प्राइम नंबर है या नहीं. ठीक है. अच्छा जी, सो दिस इज द सिग्नेचर ऑफ आवर फंक्शन. ठीक है, दिस इज द सिग्नेचर ऑफ आवर फंक्शन. किसी भी फंक्शन का सिग्नेचर क्या बताता है आपको कि उस फंक्शन का नाम क्या है, उसकी इनपुट्स क्या हैं और कौन कौन सी हैं, कितनी हैं, और उसकी आउटपुट क्या है, कौन सी है, कितनी है. ठीक है. सो दिस इज व्हाट द सिग्नेचर ऑफ अ फंक्शन टेल्स यू. सो दिस इज द सिग्नेचर ऑफ आवर फंक्शन. दिस इज द सिग्नेचर ऑफ आवर फंक्शन. अच्छा, मैं इसको कैंसिल कर देता हूँ फिलहाल. आई प्रेस द कंट्रोल प्लस एस की सिर्फ आपको बताने के लिए. अच्छा, then it is always a good idea that we put the end keyword to signify to mark the end of the function. Again मैंने control plus s press कर दिए. अच्छा जी, so this is how you write a function. Function starts with the keyword function. It should end with the keyword end. Although end is optional, अगर आप यहाँ ना भी लगाएं तो कोई फर्क नहीं पड़ता. ठीक है. So but it is always a good idea that you have an end keyword to specify or to mark the end of a function. अच्छा, फंक्शन कीवर्ड के बाद फिर क्या होता है? वो तमाम वैल्यूज़ जो आपका फंक्शन रिटर्न करेगा या एज आउटपुट जनरेट करेगा. ठीक है. सो उनकी लिस्ट. सो राइट नाउ ये जो हमारा फंक्शन है ना, इसने सिंपल एक वैल्यू रिटर्न करनी है, वो या ट्रू होगी या फॉल्स. सो वी वांट टू टेल टू द यूज़र के ये जो नंबर उसने हमें इनपुट के तौर पे दिया है, whether this number is prime or not. If this number is prime, we'll return true. if the number is if this number is uh, not prime, if it is composite, we'll return false. So that is what this function would do. Then you have the assignment operator. After that we have the name of the function is prime, और फिर इस फंक्शन को कौन कौन सी इनपुट्स चाहिए. So it needs just one input. ठीक है, and that input right now it is number, and we assume that number is scalar. We assume that number is scalar. Number can be a vector as well. ठीक है, आप एक वेक्टर भी आपको मिल सकता है, बट वी अस्यूम राइट नाउ कि नंबर इज स्केलर. ठीक है, नंबर क्या है, इट इज अ स्केलर वैल्यू. सो दिस इज व्हाट आवर assumption is. अच्छा, नाउ लेट अस सेव दिस फाइल. लेट अस सेव दिस फाइल. जब आप इस फाइल को सेव करेंगे, so the name of this file should be exactly the same as the name of this function. ठीक है, is prime. So this is how it should be named. इसमें function है is prime, so इसका नाम भी is prime होना चाहिए, और आपने small और capital दोनों का फर्क जो है ना वो याद रखना है. ठीक है, so is and then capital P R I M and then save. ठीक है, so we have created the is prime function. अभी इसमें हमने कोड नहीं लिखा कि ये क्या कर रहा है क्या नहीं कर रहा, but this is how you create a function. ठीक है, now let us write the code for this function. Now assume that you have a value stored in the variable number, और हमने पता लगाना है कि ये जो नंबर है जो कि स्टोर्ड है इस वेरिएबल नंबर में, whether this is prime or not. Now how do you do that? ठीक है, अगर आपको याद हो तो हमने ये किया था कि किसी भी नंबर को, प्राइम नंबर कौन सा होता है, प्राइम नंबर वो नंबर होता है जो वन और अपने आप के अलावा और किसी नंबर से डिवाइड नहीं होता. ठीक है, सो वन और अपने आप के अलावा और किसी नंबर से डिवाइड नहीं होता. अगर कोई नंबर ऐसा है जो कि वन और अपने आप के अलावा किसी और नंबर से भी डिवाइड होता है, तो वो भी प्राइम नंबर नहीं है. ठीक है, तो इसके पता लगाने का तरीका क्या होता है कि आप इस नंबर को डिवाइड करना शुरू करें स्टार्टिंग फ्रॉम 2 एंड गोइंग अप अंटिल हाफ ऑफ दिस नंबर, और अगर 2 से लेके इसके हाफ तक किसी भी नंबर से ये डिवाइड हो जाता है, तो इसका मतलब है कि ये प्राइम नंबर नहीं है. ठीक है, इसका मतलब है ये प्राइम नंबर नहीं है. और अगर ये ऐसा नहीं होता, किसी 2 से लेके इसके हाफ तक ये किसी भी नंबर से डिवाइड नहीं होता, तो इसका मतलब है कि ये प्राइम नंबर है. इसका मतलब है कि ये प्राइम नंबर है. अच्छा जी, तो अब ये काम हमने कैसे करना है, इसका मतलब ये है कि वी नीड टू डिवाइड दिस वेरिएबल नंबर बाय 2, देन 3, देन 4, देन 5, देन 6. ठीक है, तो और ये प्रोसेस हमने रिपीट करते जाना है. कहाँ तक करते जाना है, हमने ये प्रोसेस रिपीट करना है और हमने इसको लेके जाना है नंबर के हाफ तक. ठीक है, सो इसका मतलब ये है कि हमें लूप लगाना होगा. वी नीड टू यूज अ लूप. सो लेट अस यूज द फॉर लूप, से फॉर एग्जांपल. सो लेट अस यूज द फॉर लूप. फॉर just a second. So in order to find out whether a number is prime or not, what we need to do is we need to divide that number repeatedly, starting from 2 up until half of that number. Okay, so we are omitting 1 because 1 is already a factor of this of any number, and we are not interested in 1 because we know like every number is divided by 1. So what we need to do is we need to divide this number, the number that we get as input, the number that this function, is prime function, gets as an input. We need to divide this by numbers starting from 2 going up until half of this number. Okay, so let us call those numbers as divisors. Okay, so we or divisor, simply divisor. So we need to divide this number by divisor, and the divisor would have an initial value of 2, and it would have a final value of, say, number by 2, half of this number. Okay, and then this would be our for loop. So here we would carry out the division. So by division, we would mean that like we would divide this number by say divisor, and we look at the remainder. If the remainder is equal to 0, that means this number is divisible by divisor. If it is not equal to 0, that means it is not. Okay. So we are interested in the scenario or in the case where this particular number is divisible by divisor. Okay. Why are we interested in this case? Because once we find out that this number is divisible by any number in this range from 2 to half of this number, then we know that this number is not a prime number. We know that this number is not a prime number. Okay. So how do we find that out? So this is how we find it out. If mod, okay, so we have used the mod function or modulo function. What does the modulo function do? The modulo function takes in two input values. Okay, here on the command window I have demonstrated it. So this is the modulo function. I give it two input arguments, 5 and 2. So 5 is the dividend and 2 is the divisor. So 5 is divided by 2 and the remainder is returned. So when you divide 5 by 2, so you get 1 as remainder. That is what it does. Okay. So if 5 were completely divisible by 2, you would get 0 as a remainder. Okay. So we use this mod function to find out whether a number is divisible by another number or not. So what is the number that we want to find out whether it is divisible by some other number or not? It is the number. Okay, it is this number that we have received as input, and we want to divide it by divisor. Okay, and divisor will start from 2 and it will go up until half of this number. Okay, so if ever we find out that for any value of divisor starting from 2 to half of this number, the mod or remainder when number is divided by divisor is equal to 0. If ever we find it out, okay, this is equal to 0, then what should we do? Okay, then we know that this number is not a prime number. Okay, we know that number is not a prime number if this condition is true. If there is a number between 2 and half of this number which can divide this number, okay, so if there is such a divisor starting from 2 up until half of this number which can divide this number, that means that this particular number, this number that we have, it is not a prime number. Now how do we tell that this is not a prime number? So we say we say that a result is equal to false. Okay, so we assign the value false to our result. We assign the value false to our result. So that means that this number is not a prime number. Okay, so how would we say that this number is a prime number? Like how would we say that? Okay. So the other thing that we need to do is once we find out that this number is not a prime number, once we find out that this number is not a prime number, for example, if we want to find out whether 46 is a prime number or not, okay, so clearly 46 is not a prime number. Okay, why? Because 46 is even, it is divisible by 2. So when for the very first iteration of this loop, when you divide 46 by 2, when the divisor is equal to 2, you will get 0 as a remainder. This condition would be true. This condition would be true. And what will happen? You will execute this code. Result is equal to false. We'll set the value of result is equal to false. And that would mean that this particular number is not a prime number. So do we need to check whether it is divisible by 3, 4, 5, 6, 7, 8, 9, 10 up until 23? Because this loop is going to execute up until half of 46, which is 23. So it will start from 2 and go up until 23. So I guess that execution will not be necessary. Okay, this would waste our time, our processing time. So if you want to exit or go out of for loop prematurely, okay, like before it is done executing, you want to terminate the for loop. So you can use a command that is called break. Okay, you can use a command that is called break. So break will basically break the execution of the for loop. Okay, the next for loop, the for loop in, like, it this particular break statement lies within this if block. So it does not affect the if block, it affects the for loop. Okay, now if we have nested for loop, for example, if we have a for loop, we have an inner for loop and outer for loop. So if the break statement is within the inner for loop, so it will basically break out of the inner for loop. So it will terminate the execution of the for loop and the inner for loop, not the outer for loop. Okay. So we can use this break statement to terminate the execution of this for loop. Why? Because we have found out a factor of this particular number within this range, and we do not need to look for other factors. Okay, we already know that this particular number, it is not a prime number. Okay, it is not a prime number. Result is equal to false. Okay, so if initially like we can say result is equal to true, we can initially assume that this number is a prime number. Okay, initially we can assume that this number is a prime number. Now we can test that assumption. We can start dividing this number by 2, 3, 4, 5, 6, 7, 8, 9, 10, and up until half of this number. If anywhere we find out that there is a number which divides this number, then we set our result to false. We cancel this assumption. We set our result to false. But if we do not find any number within this range, 2 to half of this number, which can divide this number completely, then our assumption remains true and we return that value. Okay. So this is how the isPrime function would work. Now we can use this isPrime function. We can use this isPrime function to find out whether a number is prime or not. Okay. How are we going to use it? Now let's see. So you can use it from the command window as well. Say for example, we can say isPrime, and we want to find out whether 13 is a prime number or not. Okay. So answer is equal to 1. 1 means true. So 13 is a prime number. Let's find out whether 24 is a prime number or not. So the answer should be 0 or false. Okay. Now let us insert a breakpoint here. Let us insert a breakpoint here so that we know like how does this function execute. Okay. Let me call this function again for 24. Okay, so here we are. Now we have, and this function was called. Okay, and now we have like we are here. We have entered here. So now we want to see how this function executes. Okay, so initially the variable result, it is assigned. Sorry. Okay, so the variable result is assigned the value true. Okay, so result is assigned true. So we assume that this number, which is 24, we assume that it is, you cannot see the value here. Let me expand it a little bit so that you can see the value as well. Let us bring it here. So number, so here we said in the command window, we said isPrime 24. Okay, we called the isPrime function and we gave it 24 as the input value. Now that 24 value has been copied into the variable number, So inside this function isPrime, the variable number contains the value that was passed from the command line. Okay, from the command line we gave it the value 24, that is copied into the variable number. So now we have 24 stored in the variable number, and we want to find out whether 24, which is stored in the variable number, is a prime number or not. Okay. So we say, let us assume 24 is a prime number. And then we check whether our assumption is correct or not. If our assumption is not correct, we change the result, and then we break out of here. Okay, so how do we check that? So we start dividing 24 by 2, 3, okay, so on and so forth. Let's see what happens. So we set divisor equal to 2, okay. We divide number by divisor, and we look at the remainder. The remainder is equal to 0. So this condition was true. That's why we are here. Okay. So result, we say result is equal to false. We say 24 is not a prime number. Okay. And then we say break. And by break, we mean we get out of this for loop. We get out of this for loop. Okay. And then we get out of this function as well. And we return here. So answer is equal to 0. That means 24 is not a prime number. Now, if this break statement was not here, if this break statement was not here, then what would happen? So then you call the isPrime function, and we are here. Again, the same function is executing for the same input value, 24. Okay, so 24 is copied into the variable number. It is here. Next, what we do is we assign result the value true. Okay, so that we assume that 24 is a prime number. This is what it means. Then we start dividing 24, or which is stored in the variable number, by 2, 3, 4, 5, so on and so forth. Okay, so we divide it by 2, and we see that the remainder is equal to 0, and we set result is equal to false. Then we move again. We now check divisor equal. We divide it by divisor equal to 3. Okay. So in the previous execution, we had a break statement. So once we found out that there is a divisor between 2 and half of 24, which is 12, so we knew that we don't need to check for other numbers. We already know that this number is not a prime number. 24 is not a prime number. But since we have commented out the break statement, so now we are going to divide unnecessarily 24 by 3, 4, 5, 6, 7, 8, okay, and then 12. So we are going to divide it by all these numbers, and that is going to take a lot of extra time. Okay, so it's good to have the break statement. Once you know that you don't need uh, the like the loop to execute, so you should have the break statement. Okay. Okay. Now let us call the same function for a number that we know is a prime number. Say for example 31 is a prime number. So let us call it for 31 is prime 31. So when you call the isPrime function for the value 31, see, like we can call our own functions, the function that we wrote, just like the built-in MATLAB functions. So just like those functions, or just like the built-in Octave functions, we can call our own functions like that as well. So this is the beauty of writing functions. And we can use these functions in other script files as well. So I'll show that to you as well. Okay, so now we are here. So we are inside this function because we have inserted this breakpoint. So the breakpoint means that the execution of this particular function would break or would stop when it reaches this particular line on which we inserted the breakpoint. Okay, so breakpoint, it helps you like debug your code. If there is a problem in your code, so you can execute your code by a single step. Okay, so you can say step, and then you will execute your code line by line, single line by line. So you can either use this step option from the menu, or you can use the F10 key on your keyboard. Okay, so let us single step. Say I say step. So the result has been assigned. The result variable has been assigned the value true. Okay, so now we have number is 31, and we assume that 31 is a prime number, and then we check whether this assumption is true or not. How do we check? We start dividing this number 31, which is stored in the variable 30 number. We start dividing it by 2, then 3, then 4, and we see if there is a number that divides it completely, can we get a zero remainder out of it or not? That is what we are looking for. So you can single step through it. So you can single step by going to the debug menu and pressing step. Okay, so it moves to the next line. So now divisor is 2 and we divide 31 by 2, so the remainder would not be equal to 0, it would be 1. Okay, so what would happen? This condition would be false, so these statements will not be executed and you will go to the next iteration of the loop. So you will try divisor equal to 3 then. So let me press the F10 key now. So I press the F10 key, and how do you how would you know that I did that? The divisor changes from 2 to 3. Now we divide 31 by 3 and it cannot be divided. Okay, 3 tens are 30 and you get 1 as remainder. So I press F10 once again, divisor becomes 4. Okay, so now we divide 31 by 4 and it cannot be divided, you get 3 as remainder. Okay, then divided by 5 you get 1 as remainder, then divide by 6 you get 1 as remainder, then divide by 7 3 as remainder, and then divide by 8 you get 7 as remainder, then by 9 10 11 12 and then 13 14 15. Okay, so we divided it by all numbers up until half of 31. So half of 31 is 15.1, so it will be rounded off to the integer value, so it would be like 2 to 15. So when we press next, so we are going to get out of this loop. So that means like the variable number which contained 31 in this particular execution, 31 could not be divided by any number starting from 2 up until half of 31. So that means 31 is a prime number. So this particular function would return true, would return true. So if you look at your command window, so isPrime 31 returns us 1 or true as the answer. Okay. Okay, so we know how this function works, and like we know that it works fine. So let us use this function to solve another problem. So if you remember, like I asked you to write a program that finds the first 100 prime numbers. Okay, the first 100 prime numbers. So you can use the isPrime function uh, to very easily solve problems like this. Okay, how? Or you can search for, say, find the prime numbers in a given range of integers. For example, if you want to find out all the prime numbers from up until 1000, so how can you do that? This is how you can do it. Let's create another script file and let us save it. So this script file is lab2 using isPrime function. Okay, so we want to use the isPrime function in a script file. Now the isPrime function is stored in a script file with the name isPrime. We could not add the lab2 prefix to it. Then we would need to name the function as well, like lab2 isPrime. So that would seem awkward. That's why we do not have this the prefix lab2 here before the isPrime function. In any case, so what do we want to do? We want to say, for example, we want to find out all the prime numbers between, say, 2 and 1000. Say, for example, this is what we want to do. So how would you do that? So you want to find out the prime numbers starting from 2 and up until 1000, say, for example. That means you want to check whether 2 is a prime number or not, whether 3 is a prime number or not, 4, 5, 6, 7, 8, and so on up until 1000. We want to check every single number whether it is prime or not. If it is a prime number, we want to display it. Okay, this is a prime number. Okay, so let's do that. So we want to say for n is equal to we are going to do something repeatedly, like we want to see whether 2 is a prime number or not, 3 is not, 4, 5. So we are going to repeat a certain process. Okay, so that's why we need a loop. So for n is equal to 2, so we need to start from 2 and we need to go up until say 1000, and we need to find out all the prime numbers in this range. Okay, so we need to check all the numbers for primality, and we need to see which numbers are prime and which are not. Okay, how can we do that? We have written a very useful function, isPrime, and that function can help us find out whether these numbers are prime or not. Okay, so how can we use that function? Now this function it returns us a logical value, true or false. So we can use it with the if statement. So we can say if is prime. So we are calling the is prime function and we are giving it n as the input, and we are testing कि if is prime, यानी is prime function अगर if it returns a true value, if is prime n, then what should we do? Then we just need to print out कि n is a prime number. Okay, so we just need to display n, and we need to say it is a prime number, display, and then is a prime number. Okay, so we created this function is prime, and is prime returns us a logical value. Logical value means it is either true or false. And if you remember the if condition, the if statement, so the if statement, like it starts with the if keyword and then we have a condition here, and conditions are created using using relational operators. For example, here we use the equality operator. So this is a relational operator. It basically finds out relationship between the left hand side and the right hand side. So here we want to test the equality relationship. Is the left hand side equal to the right hand side or not? If it is equal, we will get a true value as the output. If it is not, if they are not equal, then we would get a false value as the output. So the outcome or output of this statement would evaluate to either true or false. If it evaluates to true, then these statements would be executed. If it evaluates to false, then these statements will not be executed. Okay, so here we have this function is prime n, and this function returns us either true or false. So if it returns a true value, that means n is a prime number and these statements should be executed. If it returns false, that means n is not a prime number and these statements should not be executed. Okay, so this code, this very simple code, will find out all the prime numbers between 2 and 1000 for us. Okay, so if we execute it, okay, so we will have all the prime numbers starting from 2 up until uh, 1000. Okay, so 2 is a prime number, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. Okay, if is prime number looks doesn't look nice, so we can change this code. We can say primes is equal to say let's start with 2. The first prime number is 2, so we are basically creating a vector of prime numbers. Okay, and let us start from 3 here. So if n is a prime number, we want to append it to the vector primes. Okay, so we want to say primes is equal to primes and then n. Okay, so we want to append it to the vector primes. Once we have all the prime numbers in this range, then we say display primes. This vector would be all the prime numbers between 2 and 1000. Okay, so this is going to be a little different. Let us clear everything and clear the command window, and let us run this code. So here we have this vector of prime numbers starting from uh, 2 to 1000. Okay, starting from 2 to 1000. So we have all the prime numbers starting from 2 to 1000. Okay, how many are these? So these are around how many? 168. There are 168 prime numbers in the first 1000 natural numbers. There are 168 prime numbers. And in the next 1000, like you can find out the number of prime numbers within a range of numbers. So you can do all sorts of modifications. Now, if you look at this code, just because you have the isPrime function, this code becomes very simple. Okay, just because you have this function isPrime, this code becomes very simple. Okay, so that is basically the utility of functions. You write a function or create a function that does a specific task, like that performs a specific task, and then you call that function whenever you need to carry out that task for a certain input value. Okay, so this it like you'll see that it makes your job of writing code very easy. Okay, so this is one function, one way of using the isPrime function. We can use it in another way as well, like if we want to find out the first, say, 200 prime numbers, so we can use it that way as well. Here this program is different. Here we wanted to find out mm, the prime numbers in the first 1000 natural numbers. Okay, and we came to know like there are 168 prime numbers in the first 1000 natural numbers. But if you want to find out, say, the first 1000 prime numbers, how can you do that? Okay, so let us do that as well. So let us find out, say, so this is lab 3. Okay, lab 3 using isPrime function. Acha. First n primes using isPrime function. Okay, so you want to find out the first n prime numbers, first 1000 or first 100 or uh, first 200 prime numbers. Okay, so we want to find those prime numbers using the isPrime function. So say for example the number of prime numbers that we want, we store that number in the variable n. Okay, say n is equal to 200. So we want to find out the first 200 prime numbers. That is what we want to do. Okay, so how are we going to do that? Now in this particular case, like we would be better off uh, if we use the while loop. Okay, because we don't know like for how many, after how many iterations. uh, so yeah, so we need to find out, we need to use the while loop, because in this particular case we know that we need to find out like 200 or n prime numbers, but we don't know like for how many numbers are we going to check in order to find out these 200 prime numbers. Okay, so we'll start from 2, and then we will like keep on going, and we will look for different numbers, and once we have 200 prime numbers with us, then we are going to stop. Okay, so how is this going to work? So the first thing that we need to do is, like, we have this variable n, okay, capital N. These are the number of prime numbers that we need to find, and let us use another variable n, small n. And small n is basically the number of prime numbers that we have found already. Okay, so this is the number of prime numbers that we need to find. Okay, number of primes we need to find, and small n is, sorry, number of primes that we have already found. Okay, so initially we have 0 primes, we haven't found any prime number, and we are going to like look for prime numbers, and we are going to stop only when we find 200 prime numbers. So while small n is less than or equal to capital N, okay, so we are going to look for prime numbers. We are going to look for prime numbers. Okay, so this is basically the while loop that will do things for us. So n is the number of prime numbers that we have already found, and capital N is the number of prime numbers that we need to find. Okay, that we need to find. And how are we going to find the prime numbers? So again, in order to find prime numbers, we need to start uh, looking for prime numbers in the set of natural numbers. So we need to start looking at, say, 2, then 3, then 4, then 5, then 6, okay, and 7 and 8, and so on and so forth. So we need to start looking at the set of natural numbers, okay. So we need another variable, and that variable would be basically a natural number that we need to test for primality, that we need to test whether it is a prime number or not. Okay, so let us call that number as number, and let us initialize it with the value 2. Okay, so first of all, we need to check whether this number is a prime number or not. Okay, how are we going to do it? So we are going to use our isPrime function. So we are going to say if isPrime, and we are going to give isPrime an input value which would be number, which stores the natural number that we need to test, that we need to check whether it is a prime number or not. Okay, if isPrime number, if it is prime, okay, then what should we do? So we have this natural number, we give this number to the function isPrime. The function isPrime tests whether this number for primality. If it returns true, if this number is indeed a prime number, what do we do? Okay, so first of all, what we need to do is we need to display this number. That is the first thing that we need to do. Okay, we need to display this number. The next thing that we need to do is we need to increment the variable n. So this is the increment operator. So increment operator would increment the variable n. Why? Because we have found one prime number, and n keeps track of the number of prime numbers that we have already found. Okay, so we found one prime number, so we increment n. So this double plus sign, it is the increment operator. Okay, it is the increment operator. It increments n by 1. It increments the variable n by 1. So if any variable, like if we say increment number, so it that will increment the variable number by 1. If we say increment capital N, okay, so that will increment the variable capital N by 1. But we don't need to increment these variables, we just need to increment small n. Why? Because this basically keeps track of the number of prime numbers that we have found, that we have already found. So we found one, we need to find 199 more. Okay, is there anything else that we need to do after we find a prime number? I guess we don't need to do anything else after we find a prime number. Okay, so after we get out of this if structure, what do we need to do? So we just checked one natural number, 2, for primality. Now we need to check the other next natural number. Okay, so what is the next natural number after 2? It is 3. So after number, the next natural number can be obtained by incrementing the variable number. So when we say increment number, we will get the next natural number. Okay. Now this condition n is less than or equal to capital N. This is not. This is true. So this statement will be like executed, and we'll come back. This condition will be tested. Small n is less than capital N, which is 200. We just found one prime number. Okay, so one is definitely less than 200. This condition will be true, and here we will check. We will test 3 for primality now. So if 3 is a prime number, which is, so we will display 3. We will increment n. So now we have 2 prime numbers, and then we will increment number as well. So next we'll check 4 for primality. Okay, so then we come back here. We already found 2 prime numbers, and 2 is less than or equal to 200. We need to find 198 more. So the next number would be 4 that will be tested for primality. 4 is not a prime number, so it won't be displayed, and we will not increment plus plus n. These statements will not be executed. Instead, we will increment number, so it will become 5. So we will check 5 for primality. Okay? And this process would go on and on until we find 200 prime numbers. Okay, so let's do that. Let us first let me insert those two statements, clear and CLC. So we are clearing the workspace variables and the command window, and then let's see. Okay, so let's first run this code like that, and then we'll single step through it. Okay, so these are the first 200 prime numbers. Okay, these are the first 200 prime numbers. You can verify each and every one that it is a prime number, and these are the first 200 prime numbers. Okay. Okay, let's say we want to find out the first 300 prime numbers. You can do that. Just change the value of capital N. So now we need to find the first 300 prime numbers. That will take a little more time. Okay, so we found the first 300 prime numbers. Okay, and okay, now let's see how does this function actually work. Let me reduce the value of n to 10. So let us run it for the first 10 prime numbers. Let us insert a breakpoint. Okay, and let us call this function. Okay, so we are here. So now we need to find out the first 10 prime numbers. Okay, so let's see how this program behaves. So we need to single step through it. Okay, so press F10. So when I press F10, capital N is assigned the value 10. Okay, so this is capital N. Okay, then press F10 again. Small n is initialized to 0, and number is initialized to the value 2. Okay, so now we need to check. We need to find the first 10 prime numbers. So the number of prime numbers that we have already found, we store that value in small n, which is 0, and the number of prime numbers that we need to find out, that is in capital N, which is 10. So right now we do not have any, we haven't found any prime numbers. So n is equal to 0, and 0 is less than or equal to 10. So this condition would be true, we will enter the while loop. So when this statement is executed, we enter the while loop, and here we check, we call the isPrime function, and we give it number or 2 as input. The isPrime function operates like it executes, and it finds out that 2 is a prime number. It returns true. So that's why we are here. So 2 is displayed on the screen, and we increment small n because we have just found one prime number, and then we are ready to check or look for another prime number. So the other prime number we would look for it in the next natural number. So we started with the natural number 2, and now we increment it, so it becomes 3, and we want to check out whether 3 is a prime number or not. Okay, so we get back here, small n is still less than or equal to capital N, and we want to find out whether now 3 is a prime number or not. So number is equal to 3. 3 is also prime number, so the function isPrime would return true. We will display 3, we will increment small n because we have found another prime number, and then we will look for another prime number in 4. Okay, so 4 is not a prime number, so we need to check out 5. 5 is a prime number, we display it, and we have just found third prime number. Now we go and check 6. 6 is not a prime number. We check 7. 7 is a prime number. Display, we found 4 prime numbers. 8 is not a prime number. 9 is not a prime number. 10 is not a prime number. 11 is prime. Okay, so we just found 5 prime numbers. 12 is not a prime number. 13, it is a prime number, so we display it, and we found 6 prime numbers. 14 is not a prime number. See, 15 is not a prime number. 16 is not a prime number. 17 is prime. We display it, we increment, we found 7 prime numbers. 18 is not. 19 is. Okay. 20 is not. 21 is not. 22 is not. 23 is a prime number. We display it. Now we have found 9 prime numbers. 24 is not a prime number. 25 is not a prime number. 26 is not a prime number. 27 is not. 28 is not. 29 is a prime number. So we display it, and 29 is our 10th prime number, and we are done. Okay. We should be done. Okay. It is n less than or equal to n. So it starts from 0, that's why like it runs an extra iteration. Let us go through. So okay, let me remove this toggle point. So I hope like you have and you understand how this code performs, like how does it carry out its task. Okay, so these are the first 10 prime numbers: 1 2 3 4 5 6 7 8 9 10 11. Sorry, 11. If we want to 10, so we need to modify this condition, n is less than or equal to capital N. So now we'll have 10. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, so this is how we can use the isPrime function in useful ways, and it can make our life very easy. Okay, now I want to do one more quick demonstration of a function that returns more than just one value, and after that like we will end this session. So say we want to write a function that finds out the mean value of a vector, and it also finds out the variance of a vector. Okay, so what is the variance of a vector? So I hope like you have some introduction to statistics even like in your matriculation or FSC. So variance is basically if you have a vector and the values of that vector, like they are basically, say for example, they are random. So there's one quantity which we have already found out, that is the mean or average value, and the average value is the average of all the values in the vector, and it is usually different from each value of the vector. Okay, so the average is different. Uh, and if you want to find out like how far away is individual value of a vector from the mean value, so you can quantify that using the quantity that we call the variance. Okay, uh, let me demonstrate it. How can I demonstrate? I hope like you've heard the name terms variance and standard deviation. Okay, so variance is basically, or standard deviation is, and they are the same. Standard deviation is the square root of variance. Okay, so variance is basically, for example, if you have, let us go to the slideshow. Let me get a marker. Okay, pen. So say for example, we this is our x-axis and this is our y-axis. This is our x-axis. This is our y-axis. Say for example, we have a signal, and this is the signal. Say for example, okay. It is basically vector of values. Okay, so this is the signal. Now its mean value would be somewhere here. Its mean or average would be somewhere here. Okay, this would be the average value of the signal, or the mean value of the signal. So I've drawn it as a straight line because this is going to be a constant value. There are no fluctuations in it. Now this is the mean value. This is very simple, straightforward, understood, easily understood. Now what is the variance? The variance basically measures the average distance of individual points from the mean value. Say for example, this point, it is at this distance, this point is at a greater distance, this point is at an even greater distance. Now these distances are positive and these distances are negative. Okay, so what is the average distance of these points from the mean? So that is measured by variance. Now the formula for variance is, so it is also a single number. So what you do is basically you find out the distance, the square of the distance between individual values of the signal, say xi, from the mean. So this is the mean of the signal, or the vector x. So you subtract the mean from individual values of the signal. So this is, say, x, ith value of x. I can be anything here. Say I can be 2 or 3 depending upon like what is the index of this value. So you subtract the mean from this value and you take its square. Okay, so you do this operation for every single value in the vector x, and then you divide it by n to find out the average of this square distance. Okay, so this basically is your variance. So we can show it as square. It is basically the square distance of the mean square distance of every single point in the vector x from the from the from the mean of x. Okay, so that is what it is. So you can look it up. You can look up variance and you can find out like what it is. So let us write a function that calculates these two quantities. Okay, so let us create a script file, and uh, let us call this function as we'll give it the name stats. Okay, stats. So stats means statistical values or quantities. Okay, so it will get some vector v that is represented by some vector x as input, and this function will calculate these two statistics for this function, this particular vector. So one statistic would be the mean value. Let us call it as the mean value, mean val, and the other would be the variance. Okay, variance. So we want to find out the mean value and the variance for this particular uh, uh, vector x. Okay, this is what we want to do. Okay, now let us save this script file, and we have to save it using the same name as the name of the function. We call it stats. Okay, we call it stats. Stats or statistics of a vector x. Okay. So in order to find these stats, we need to like so this is the function. Its name is stats. It gets an input x. It gets a vector x as input, and it has to find out these two values: the mean value of x and the variance of x. Okay, so it needs to find out these two values. So how can we find out the mean value? First of all, let us initialize the mean value with 0 and the variance with 0 as well. Okay, so these are the initial values, and then let us find these two values. So first we need to find out the mean value of the vector x. So how are we going to find out the mean value? So the mean value is sum of all the elements in x divided by the length of x. Okay, so we need a loop. So loops are very fundamental. You are going to need them everywhere. So let us find out. So we need to find the sum of all the elements and then divide it by the length to get the mean value. So uh, starting from the first element of vector x, and let us use c as the index, up to length of x. Okay, so what do we need to do? We need to add all the values of vector x. Okay, and we are going to access those using the index c. So c is the index. We access the first element, then the second, third, fourth, up until the length of x. We sum them all. The sum would be stored in the variable sum, and then we find out the mean value. How do we do that? We divide the sum by the length of x. Okay. Okay. Next, we need to find out the variance. How do we find out the variance? Okay. So again, in order to find out the variance, what do we need to do? We need to subtract the mean value from every single value of the vector x. We need to square the difference and sum it. Okay, so we need to find the sum of the square of the difference of individual elements of vector x with the mean, and in the end we need to find its average value. So how can we do that? So again we need to find the sum. Okay, if you look at this formula, we need to find this summation. Okay, summation of all the elements of vector x, the difference of all the square of the difference of all the elements of vector x with the mean value. So we need to find this summation. How can we do that? So we can reuse this sum variable. Okay, we can reinitialize it to 0. Let us say sum is equal to 0. We have already used it to find out mean value, so we have the mean value stored in the variable mean value, and now sum is free. We can reuse it. We don't need to declare another sum variable. Okay, and then again we need to reuse this loop. We can reuse c as the loop counter. Okay, Acha. what are we going to do here? Sum is equal to sum plus what? Sum is equal to sum plus not this thing. We need to find out the difference of xc, the ith value or cth value in vector x. We need to find its difference with the mean value, and we need to square it. Okay, we need to square it. How do we square it? We can use the exponentiation operator. We can use the exponentiation operator. So this is the cth element or ith element. Okay, so we are using c as the index or for elements of vector x. We are not using I. So this is the cth element of x. We subtract the mean value from it, we take its square, and we add it to the variable sum. So we are finding out, we are basically evaluating this summation here. Once we have determined this sum, so then we can find out the variance. So variance would be sum divided by the length of vector x. That would be the variance. Okay. Okay. So this particular function, when we call this function, it would return these two values, mean value and variance. Okay. These are the two values that it would return for any vector x. So let us try it out. Let us clear the workspace and let us create a vector, any vector v, say v is equal to a random integer, say, and say the maximum value is 10, and the dimensions are 1 by say 20. Let us give these values, let us give them a range -10 to 10. Minimum value is -10, maximum is 10. Okay, so this is the vector x. It has both positive and negative values. Okay. Okay, and let us give this vector to the function stats v. Okay, so stats v returned us just one value. No, it should return us two values. Okay, how are we going to get both the values? So this is how we are going to get both the values. A b is equal to stats v. Okay, so we are assigning these two variables a and b the output of the function stats. Okay, so the stats function returns us two values. So a is equal to 0.4, that is the mean value. B is equal to 30.44, that is the variance. That is the variance. Okay. So this is how you can write functions. So in this particular session, we talked about functions, what they are. We talked about the syntax or grammar of function creating function. If you want to create or write your own function, what should be the syntax? What syntax you should follow? How should you declare that this is my function? Okay, so you use the keyword function. You specify the list of output values. You then use this assignment operator, like you assign to these two variables, output variables, you assign the value of this function. This is the name of your function stats, and this is the input that it requires. So you can call this function using this name. You give it a vector as an input, and it would return you these two values as an output. Okay? And we wrote this simple function which returned a single value. Okay, and this value was logical, it was not numerical, it was either true or false. So I hope after this session you'll know how to write functions, and these are some tasks, like you should write an average function that finds the average of a vector. I'm not going to give you share with you this code, so you should rewrite the isPrime function and the stats function, and maybe you can make a small change into it, like you can find the standard deviation and the mean. Similarly, you should also write the isPerfect function, the max function, the min function, maximum function. Call them maximum or minimum because max and min are built-in functions. So you should have different names for these functions. Is perfect function. The is perfect function should find out whether a given integer is perfect or not. So what is a perfect integer? If the sum of the factors of the sum of the proper factors of an integer is equal to that integer, then that integer is a perfect number. So I guess we have talked about this perfect numbers. So hopefully you won't have any problem attempting these tasks. Okay. So if there are any questions, you can let me know and we'll discuss those questions. Until then, Allah Hafiz.